Hello, in this lecture we will answer on two questions. The first question is to find out the diameter of this orange circle, and the second question is to find out the size of this angle theta. So we will start with the first question. In the drawing we have three semicircles. The biggest semicircle consists of two small semicircles and one orange circle. We know that the diameter of this small semicircle is equal to 10 units, therefore the radius is equal to 5 units. The diameter of this semicircle is equal to 20 units, therefore its radius is equal to 10 units. And the diameter of the biggest semicircle is equal to 10 plus 20 units, that is to say it equals to 30 units, therefore its radius is equal to 30 over 2 is 15 units. And we want to find out the diameter of this orange circle. So we will define the diameter of this orange circle. We will define the radius of this orange circle as R. Write it down. So R small r is the radius of the orange circle and we also know that the center of this orange circle is at this point, and this point is defined as point C. So we will define the center of the smallest semicircle as point X. We will define the center of the biggest semicircle, this semicircle, as point Y, and we will define the center of this semicircle that is radius equal to 10 units as Z. In the next step, we will join the centers of the three semicircles with the center of the orange circle that is located at this point, point C. And in order to find out the length of the line segments that we created here, I'll present to you two new rules. The first rule, actually, it is about the way that two circles can touch each other at one point. There is two types of tendency between two circles. The first type of tendency between two circles is the external launch. In this case, those two circles are touching each other externally at this point. This is the point of tendency between the two circles. We know that the radius of the small circle, this circle, is equal to small r, and the center of this small circle is at point M. And we also know that the center of the big circle is at point O, and the radius of this big circle is equal to capital R, and the distance between the center of the small circle and the big circle, that is to say the length of line segment MO, it will be equal to the sum of the lengths of the radii of the circles. In this case, line segment MO will be equal to small r plus capital R. So actually, whenever you have an external launch between two circles, like in this drawing, then the distance between the centers of the two circles will be equal to the sum of the lengths of their radii. In this case, it will be equal to small r plus capital R. And we also have a second type of tendency between two circles. If two circles are touching each other at one point internally, then it is defined as internal launch, like in this drawing. Those two circles are touching each other internally at this point. This is the point of tendency. And in this case, the distance between the centers of the two circles, that is to say the length of line segment MO, it will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. So, in conclusion, when you have an external launch between two circles, that is to say if the two circles are touching each other externally, then the distance between the centers of the two circles is equal to the sum of the lengths of their radii. In this case, it will be equal to capital R plus small r, while if there is an internal launch between two circles, like in this drawing, then the distance between the centers of the two circles will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R or small r. So we use those two new rules in order to find out the length of the line segments that we created here. So, what is the length of line segment CX? here the length of line segment CX will be equal, again, C is the center of the orange circle that is reduced is equal to small r. X is the center of the smallest semicircle that is radius is equal to 5, and those two semicircle and the orange circle have an external knot between them at this point. That is to say, they are touching each other externally at this point. And remember, we have two circles that have an external knot between them. Then the distance between their centers, that is to say Cx, will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of the small semicircle that is equal to 5 units, plus the radius of the orange circle that is equal to small r. So in conclusion, Cx will be equal to 5 plus small r. Okay, Cx equals to 5 plus small r. Likewise, we'll find out the length of line segment CY. Here we know that C is the center of the orange circle, Y is the center of the biggest semicircle, that its radius is equal to 15 units, and the orange circle and the biggest semicircle have an internal knot between them at this point. That is to say, they are touching each other internally at this point. This is the point of tendency. And whenever we have two circles that have an internal knot between them, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest semicircle that is equal to 15 units, minus the radius of the orange circle that is equal to small r. So in conclusion, we found out that Cy, the length Cy, is equal to 15 minus small r. And what is the length of line segment CY? CZ. CY is equal to 15 minus r. CZ C is the center of the orange circle. Z is the center of this semicircle that its radius is equal to 10 units. And the orange circle and this semicircle have an external notch between them at this point. That is to say, they are touching each other externally at this point. This is the point of tendency between them. And whenever you have an external notch between two circles, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle that is 10 units, plus the radius of the orange circle that is small r. So in conclusion, we found out that line segment CZ is equal to 10 plus small r. Likewise, we will find out the value of line segment XY. X is the center of the smallest semicircle, Y is the center of the biggest semicircle, and the smallest semicircle and the biggest semicircle have an internal notch between them at this point, point A. And whenever we have two circles or semicircles that have an internal notch between them, then the distance between their centers will be equal to the difference between the lengths of their radii. That is to say, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of the smallest semicircle, that is 5, and 15 minus 5 is equal to 10 units. So we found out that xy is equal to 10 units. And finally, we'll find out the length of line segment xz. X is the center of the smallest semicircle with radius of 5 units. Z is the center of this semicircle with radius of 10 units. And those two semicircles have an external notch between them at point P. That is to say, they are touching each other externally at this point, point P. And whenever you have two circles or semicircles that have an external notch between them, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, it will be equal to the radius of this semicircle, that is 10 units, plus the radius of the smallest semicircle, that is 5 units. So xz equals to 10 plus 5, that is 15 units. So we found out that the length of line segment xz is equal to 15 units. So we actually found out all the lengths of the line segments in this drawing. And in the next step, I will present to you a new law, that is the law of cosines. The law of cosines is true in any triangle. So here I will draw triangle ABC, that could be any triangle. This is triangle ABC. We know that side AB of triangle ABC equals to A units in its length. Side BC of this triangle equals to B units in its length. And side AC of triangle ABC equals to C units in its length. And we also know that the angle between side AB and side BC is angle theta. Then, according to the law of cosines, C square is equal to A square plus B square minus 2 times A times B times cosine theta. And this equation is true in any triangle. Actually, the Pythagoras theorem is a special case of the law of cosines when theta is equal to 90 degrees. When theta is equal to 90 degrees, then we have here a right triangle, and we, in the right triangle, we use the Pythagoras theorem. So here, if theta equals to 90 degrees, then cosine of 90 degrees is equal to 0. So here we get that cosine 90 degrees equals to 0, and 0 times 2 times AB, it is 0. So we get that if theta equals to 90 degrees, then this expression minus 2 times AB cosine 90 degrees is equal to 0. And we get the Pythagoras theorem, c squared equals to a squared plus b squared. That is to say, it will be the Pythagoras theorem that states that the square of the hypotenuse equal to the sum of the squares of the perpendiculars. So in conclusion, the Pythagoras theorem is a special case of the law of cosines when theta equals to 90 degrees, and then we have a right triangle. Okay, so we will copy triangle XCY in a new page, and we will implement the law of cosines in this triangle, triangle XCY. So this is triangle CXY that I copied from the original drawing. We have already found out that the length of side CX is equal to 5 plus R. And we have already found out that XY equals to 10 units. And CY is equal to 15 minus R. And this is, of course, angle theta. So we will implement the law of cosines in this triangle, triangle CXY. This will be equation number 1. According to equation number 1, we will get it CY squared is equal to CX squared plus XY squared minus 2 times CX times XY times cosine theta We know the values of cy, cx, and xy, so we'll substitute cy, cx, and xy by the values that we found for those two variables, and we'll get that according to equation number 1, cy squared is equal to 15 minus r squared that equals to cx squared. Cx equals to 5 minus r squared plus xy squared. Xy equals to 10, so xy squared equals to 10 squared, that is 100. Minus 2 times cx is 5 plus r times xy, that is 10, times cosine theta. Here we will open the brackets on both sides of equation number 1, and we will get that according to equation number 1, 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15 times r is minus 30r, and it is equal to 5 minus r squared. 5 minus r squared equals to 5 squared, that is 25, plus r squared minus 2 times 5 times r, it is minus 10r, plus 100 minus 2 times 10 is minus 20 times 5 plus r times cosine theta. So we have r squared on both sides of equation number 1, so r squared will get cancelled. And what is left from equation number 1 after we cancelled r squared? What is left? Actually, in this side we have 225 minus 35 minus 30r. 225 minus 30r. And in the other side of equation number 1, we have 25 plus 100 is 125. Minus 10r minus 20 times 5 plus r times cosine theta. Here we will subtract 225 from equation number 1, and we will get that 225 minus 125 is 100. We subtract also, we will add to equation number 1 2r. So minus 30r plus 2r is minus 20r. That is equal to minus 20 times 5 plus r times cosine theta. Here we will multiply equation number 1 by minus 1, and we get that according to equation number 1, 20r minus 100 equals to 20 5 plus r times cosine theta. Here we will divide equation number 1 by 20 times 5 plus r, and we will get that according to equation number 1, cosine theta equals to 20r minus 100 over 20 times 5 plus r. So here we will divide both the numerator and the denominator of this side of equation number 1 by 20, and we get that 20r over 20 is r, minus 100 over 20 is minus 5, over 20 over 20 is 1, so in the denominator we left with 5 plus r. So here so according to equation number 1, we found out that cosine theta is equal to r minus 5 over 5 plus r. In the next step, we will implement the law of cosines on triangle XCZ. So we'll copy triangle XCZ in a new page, and we will implement the law of cosines in this triangle, triangle XCZ. Okay. So this is triangle CXZ. We have already found out that CX equals to 5 plus R. XZ is equal to 15 units. And CZ is equal to 10 plus R. So we will implement the law of cosines on this triangle, triangle CXZ. According to the law of cosines, according to the law of cosine, this will be equation number 2. We get that CZ squared equals to CX squared plus XZ squared minus 2 times CX times XZ times cosine theta we have already found out that CZ is equal to 10 plus R, therefore CZ squared will be equal to 10 plus R squared and it is equal to CX squared, that is 5 plus R squared, plus XZ squared. XZ is equal to 15, so XZ squared is 15 squared, that is 225. Minus 2 times 5 plus R times 15 is minus 30 times 5 plus R times cosine theta So here we open the brackets on both sides of equation number 2 and we get that according to equation number 2 10 plus R squared equals to 10 squared, that is 100, plus R squared plus 20 times R, that is equal to 5 plus R squared. 5 plus R squared equals to 5 squared, that is 25, plus R squared plus 10R plus 10R plus 225 minus 30 times 5 plus R times cosine theta. But here, actually, in equation number 1, we have 15 minus R squared equals to 5 plus R squared. It is actually 5 plus R squared. It is 5 plus R squared. And 5 plus R squared equals to 5 squared, that is 25, plus R squared plus, not minus 10R, but plus 10R. And here we will have 225 plus 30R, and here in the other side of the equation we have 125 plus 10R. So here we have to subtract from equation number 1 10R, so it will be 20R, 30R minus 30r minus 10r, it is minus 40r. It is minus 40r. And here also it will be 100 minus 40r. So here we'll have 40r minus 100. So here we actually have to divide equation number 1 by 20 times 5 plus r, but here 40r over 2 40r over 20r. Here we'll have 40r minus 100 over 20 times 5 plus r. So here we divided both the numerator and the denominator of equation number 1 by 20. So 40r over 20r is 2r minus 100 over 20 is minus 5. 20 over 20 is 1. So in conclusion, we got that 2r minus 5, 2r minus 5 over 5 plus r equals to cosine theta. Here I'll write it again. 2r minus 5 over 5 plus r, it is equal to cosine theta. This is according to equation number 1. And here we continue with equation number 2. We have r squared on both sides of equation number 2, so r squared will get cancelled. So in this side of equation number 2 we have 100 plus 20r, that is equal to 225 plus 25 is 250. Plus 10r minus 30 times 5 plus r times cosine theta. So here we'll subtract 250 from this equation, equation number 2, and we'll get that 100 minus 250 is minus 150. And we'll subtract 10r from this equation, equation number 2, and we will get that 20r minus 10r is 10r plus 10r, and it is equal to minus 30 times 5 plus r times cosine theta. Here we will multiply equation number 2 by minus 1. So, and we will get that according to equation number 2, 150 minus 10r is equal to 30 times 5 plus r times cosine theta. Here we will divide equation number 2 by 30 times 5 plus r, and we will get that according to equation number 2, cosine theta is equal to 150 minus 10r over 30 times 5 plus r. So here we will divide both the numerator and the denominator on this side of equation number 2 by 10, and we get that 150 over 10 is 15, minus 10r over 10 is minus r, 30 over 10 is 3. So we actually found out that according to equation number 2, cosine theta is equal to 15 minus r over 3 times 5 plus r. But according to equation number 1, we have already found out that cosine theta is equal to 2r minus 5 over 5 plus r. So we actually have two different expressions for cosine theta. In the next step, we will create equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So cosine theta according to equation number 1 equals to 2r minus 5 over 5 plus r, and it must be equal to cosine theta according to equation number 2, that is actually equals to 15 minus r over 3 times 5 plus r. Here we will multiply equation number 3 by 5 plus r. So 5 plus r will get cancelled in the denominator. In the next step, we will multiply equation number 3 by 3, and we get that according to equation number 3, 3 times 2r minus 5 equals to 15 minus r. We'll open the brackets on this side of equation number 3, and we will get that according to equation number 3, 3 times 2r is 6r, 3 times minus 5 is minus 15, and it is equal to 15 minus r. Here we will add to equation number 2, we will add to equation number 3r, and we will also add 15, and we will get that according to equation number 3, 6r plus r is 7r, 15 plus 15 is 30, so in conclusion we got that according to equation number 3, 7r equals to 30. We'll divide equation number 3 by 7, and we get that according to equation number 3, the radius of the orange circle equals to 30 over 7 units. But we want to find out the diameter of the orange circle. The diameter of the orange circle is twice as large as the radius. Therefore, the diameter . of the orange circle is equal to 2 times the radius, that is 2r, that is to say it equals to 2 times 30 over 7. 2 times 30 over 7 is 60 over 7 units, or in terms of numbers it equals to 8.5714 units. So that is the answer to the question, that the diameter of the orange circle is equal either to 60 over 7 units, or in terms of numbers it equals to 8.5714 units. Okay, I repeat again, the diameter of this orange circle is equal to either 60 over 7 units, so in terms of numbers it equals to 8.5714 units. In the next step I'll summarize the lecture. Actually, we wanted to find out the diameter of this orange circle. We have in the drawing we have 3 semicircles. The biggest semicircle consists of 2 small semicircles and the orange circle. We know that the radius of this semicircle equals to 5 units. The radius of the biggest semicircle is equal to 15 units, and the radius of this semicircle is equal to 10 units. We define the radius of the orange circle as small r, and the center of this orange circle is at point C. So we defined the centers of the 3 semicircles. The center of the small semicircle is defined as x. The center of the biggest semicircle was defined as y, and the center of this semicircle was defined as z. Then we connected together the centers of the 3 semicircles with the center of the orange circle that is located at point C. And in order to find out the lengths of the line segments that we created here, we use 2 new rules. The first new rule actually is when you have 2 circles that touching each other at one point, then there is 2 types of tendency between 2 circles. The first type of tendency is the external nudge, like in this drawing. Those 2 circles are touching each other externally at this point. This is the point of tendency between those 2 circles. And here, the distance between their centers will be equal to the sum of the lengths of D and DI. In this case, it will be equal to capital R plus small r. So the external lunge is the first type of tendency, and the second type of tendency between 2 circles is the internal lunge. The internal lunge is when the 2 circles are touching each other internally, like in this drawing. Those 2 circles are touching each other internally, At this point, this is the point of tendency, and whenever two circles are touching each other internally, then the distance between their centers, that is to say the length of line segment MO, will be equal to the difference between the lengths of their radii. In this case, it will be equal to capital R minus small r. So we implemented the two new rules in order to find out the length of the line segments in this drawing. We found out first of all the length of line segment CX. C is the center of the orange circle, that is reduces small r. X is the center of the smallest semicircle, that is reduces 5 units. Those two, the circle and the semicircle, have an external length between them at this point. This is the point of tendency between the orange circle and the semicircle, and whenever you have two circles with an external length between them, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, in this case, Cx will be equal to the radius of the orange circle, that is small r, plus the radius of the small semicircle, that is 5. So we found out that Cx equals to 5 plus r. Then we found out the length of line segment Cy. C is the center of the orange circle with radius of small r. Y is the center of the biggest semicircle with radius of 15. And actually, the biggest semicircle and the orange circle have an internal length between them at this point. That is to say, they are touching each other internally at this point. This is the point of tendency. And remember, you have two circles that are touching each other internally, then the distance between their centers will be equal to the difference between the lengths of their radii. In this case, it will be equal to the radius of the biggest semicircle, that is 15, minus the radius of this circle, that is small r. So in conclusion, we found out that Cy equals to 15 minus r. Likewise, we found out the length of line segment CZ. The length of line segment CZ is C is the center of the orange circle with radius of r. Z is the center of this semicircle with radius of 10. The orange circle and this semicircle have an external length between them at this point. That is to say, they are touching each other externally at this point. This is the point of tendency. And whenever you have two circles that are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case, it will be equal to the radius of this semicircle, that is 10 units, plus the radius of this orange circle, that is r. So in conclusion, we found out that Cz equals to 10 plus r. Likewise, we found out the value of the length of line segment xy. Here, x is the center of the smallest semicircle, y is the center of the biggest semicircle. The biggest semicircle and the smallest semicircle have an internal length between them at this point A. And whenever you have two circles with an internal length between them, then the distance between their centers will be equal to the difference between the lengths of their radii. So the radius of the biggest semicircle is 15, the radius of the smallest circle is 5, so and the difference between the two radii is 15 minus 5, that is 10. So we found out that xy equals to 10 units. And finally, we found out the length of line segment xz. X is the center of the smallest semicircle with radius of 5. Z is the center of this semicircle with radius of 10. Those two semicircles have an external length between them at point P, and whenever we have two circles with an external length between them, then the distance between their centers will be equal to the sum of the lengths of the radii. And so it will be equal to the radius of this small semicircle, that is 5 units, plus the radius of this semicircle, that is 10 units. 5 plus 10 is 15. So we found out that xz equals to 15 units. In the next step, I presented to you the law of cosines. The law of cosines is true in any triangle. So if we have here triangle ABC, that could be any triangle. According to the law of cosines, c squared equals to a squared plus b squared minus 2 times ab times cosine theta. This is true in any triangle. And the Pythagoras theorem is a special case of the law of cosines when theta equals to 90 degrees. When theta equals to 90 degrees, then we have here a right triangle, and so theta equals to 90 degrees, therefore cosine theta is equal to 0. 0 times anything is 0. So this expression 2ab cosine theta will be equal to 0. And we left only with c squared equals to a squared plus b squared. That is actually the Pythagoras theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, in conclusion, the Pythagoras theorem is a special case of the law of cosines when theta equals to 90 degrees. And then we will have a right triangle, and we will get the Pythagoras theorem that c squared equals to a squared plus b squared. Okay, so we implemented the law of cosines in our triangle CXY. So I copied triangle CXY in a new page, and we implemented the law of cosines in this triangle CXY. We have already found out that Cx equals to 5 plus r, xy equals to 10 units, and cy equals to 15 minus r. So according to the Pythagoras theorem, we get here that cy squared equals to cx squared plus xy squared minus 2 times cx times xy times cosine theta. So we substituted cx by 5 plus r, we substituted xy by 10, and we substituted cy by 15 minus r, and we got this equation that 15 minus r squared equals to 5 plus r squared plus 100 by minus 2 times r plus 5 times 10 times cosine theta. We open the brackets on both sides of equation number 1, and we got that 15 minus r squared equals to 15 squared, that is 225, plus r squared minus 2 times 15r is minus 30r, and we open the brackets here also. 5 plus r squared equals to 5 squared, that is 25, plus r squared plus 2 times 5 times r is plus 10r, and we have also here plus 100 minus 25 minus 20 times 5 plus r times cosine theta. So here we have r square, on both sides of the equation number 1, so r square will get cancelled. And what is left after we cancelled r square from equation number 1? What is left from equation number 1 is that here we have 225. Okay, but here we have minus 30r, and here we have 10r. We subtracted 10r from this equation number 1, and we got that minus 30r minus 10r is minus 40r. And it equals to 25 plus 100 is 125. So actually, here 10r will get cancelled because we already subtracted 10r and we got minus 40r, and then minus 20 times 5 plus r cosine theta. Then we subtracted 125 from this equation number 1, and we got that 225 minus 125 is 100 minus 40r, and it is equal to minus 20 times 5 plus r times cosine theta. Here we multiply the equation number 1 by minus 1, and we got that minus 40r times minus 1 is 40r, 100 times minus 1 is minus 100, and it will be equal to 20 times 5 plus r times cosine theta. We divided the equation number 1 by 20 times 5 plus r, and we got that according to equation number 1, 40r minus 100 over 20 times 5 plus r equals to cosine theta. Here we divided both the numerator and the denominator of equation number 1 by 10, we divided both the numerator and the denominator of equation number 1 by 20, and we got that 40r over 20 is 2r, minus 100 over 20 is minus 5, 20 over 20 is 1, so in the denominator we left only with 5 plus r. So in conclusion, we found out that cosine theta according to equation number 1 equals to 2r minus 5 over 5 plus r. Then I copied triangle CXZ in a new page, and we implemented the law of cosines in this triangle CXZ. Here this is triangle CXZ. We know that CX equals to 5 plus r, XZ equals to 15, and CZ equals to 10 plus r. So we implemented the law of cosines in this triangle CXZ. According to the law of cosines, CZ squared equals to CX squared plus XZ squared minus 2 times CX times XZ times cosine theta. Then we substituted CZ by 5 plus r, we substituted CZ by 10 plus r, we substituted CX by 5 plus r, and we substituted XZ by 15, and we got this equation number 2 that says that 10 plus r squared equals to 5 plus r squared plus 15 squared, that is 225, minus 2 times 5 plus r times 15, that is actually minus 30 times 5 plus r cosine theta. We open the brackets on both sides of equation number 2, and we got that 10 plus r squared equals to 10 squared, that is 100, plus r squared, plus 2 times 10 times r is 20r, and it equals to 5 plus r squared. 5 plus r squared equals to 5 squared, that is 25, plus r squared, plus 2 times r times 5, that is 10r, plus 225 minus 30 times 5 plus r times cosine theta. Here we have r squared on both sides of the equation, so r squared will get cancelled. And what is left after we cancelled r squared from equation number 2? What is left is, in this side we have 100 plus 20r, that is equal to 225 plus 25 is 250, plus 10r, minus 30 times 5 plus r times cosine theta. Here we subtracted 250 from this equation, so 100 minus 250 is minus 150, and we also subtracted 10r from this equation, equation number 2, so 20r minus 10r is 10r. So in this side of equation number 2 we have minus 150 plus 10r, and in the other side of equation number 2 we left only with minus 30 times 5 plus r times cosine theta. We multiply the equation number 2 by minus 1, and we got that minus 150 times minus 1 is 150, and 10r times minus 1 is minus 10r, minus 30 times minus 1 is 30, so in conclusion we found out that 150 minus 10r equals to 30 times 5 plus r times cosine theta. Then we divided equation number 2 by 30 times 5 plus r, and we got that according to equation number 2, cosine theta equals to 150 minus 10r over 30 times 5 plus r. Then we divided both the numerator and the denominator on this side of equation number 2 by 10, and we got that 150 over 10 is 15, minus 10r over 10 is minus r, 30 over 10 is 3. So in conclusion, we got that cosine theta equals, according to equation number 2, cosine theta equals to 15 minus r over 3 times 5 plus r. I'll repeat again, according to equation number 2, we found out that cosine theta equals to 15 minus r over 3 times 5 plus r. But according to equation number 1, we have already found out that cosine theta equals to 2r minus 5 over 5 plus r. Then we created equation number 3 that states that cosine theta according to equation number 1 must be equal to cosine theta according to equation number 2. So according to equation number 3, cosine theta according to equation number 1, that is 200 minus 5 over 5 plus r, must be equal to cosine theta according to equation number 2, that is equal to 15 minus r over 3 times 5 plus r. Okay, then we multiplied equation number 3 by 5 plus r, so 5 plus r will get cancelled in the denominator, and we left only with 2r minus 5, that is equal to 15 minus r over 3. We multiplied equation number 3 by 3, and we got that 3 times 2r minus 5 equals to 15 minus r. We open the brackets here, and we got that 3 times 2r equals to 6r. 3 times minus 5 equals to minus 15, and it is equal to 15 minus r. Here we added r to this equation, and we added also 15 to this equation, equation number 3, and we got that 6r plus r is 7r, and 15 plus 15 is 30. So in conclusion, I found out that according to equation number 3, 7r equals to 30. We divided equation number 3 by 7, and we got that the radius of the orange circle is equal to 30 over 7 units. And we want to find out the diameter. The diameter is twice as large as the radius, so the diameter will be equal to 2r, and 2r is actually 2 times 30 over 7. 2 times 30 over 7 is 60 over 7. So in conclusion, we found out that the diameter of this orange circle is equal to either 60 over 7 units, or in terms of numbers, it equals to 8.5714 units. We finished with the first question. In the next step, I will present to you the second question. We have here a quarter circle. Inside this quarter circle, we have square ABCO, and we also have here angle AMB, that is a right angle, that is to say it equals to 90 degrees. And we also have here inside the quarter angle BQC, that is equal to theta, and we want to find out the size of angle theta. So in order to find out the size of angle theta, we will make a construction. We will extend line segment MA by a straight line. We will extend also line segment QO by a straight line until they intersect with each other. Okay? And we will define the intersection point between extended line segment MA and extended line segment QO as point N. In the next step, we will complete the quarter circle to a semicircle. So we have here a semicircle that we created from the quarter circle. In this semicircle, we have the peripheral angle NMQ, that is equal to 90 degrees. I will repeat again. Inside this semicircle, we have peripheral angle NMQ, that is equal to 90 degrees. I will present to you a new rule number 1, that is related to peripheral angle that is equal to 90 degrees. According to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. I will write it down. Any peripheral angle that is equal to 90 degrees must rest on the diameter. I will read rule number 1 again. According to rule number 1, any peripheral angle that is equal to 90 degrees according to rule number 1, any peripheral angle that is equal to 90 degrees must rest on the diameter. So according to rule number 1, we have the peripheral angle NMQ that it is equal to 90 degrees according to what is given us in the question. Therefore, according to rule number 1, the peripheral angle NMQ must rest on the diameter. That is to say, NQ is the diameter of the semicircle. Okay, NQ is the diameter of the semicircle according to rule number 1. Okay, and Q is the diameter of the semicircle according to rule number 1. And because of the fact that we have here a quarter circle, this is a quarter circle, then QO must be equal to the radius of the quarter circle and also the radius of the semicircle. So we'll define the radius of the quarter circle and the semicircle as capital R. Therefore, actually, QO will be equal to capital R, that is the radius of the quarter circle and the semicircle also. They have, of course, the same radius. And QN, it is the diameter, therefore it is twice as large as the radius, so QN is equal to 2R, or 2 times capital R. And what is the value of NO? NO, from the drawing, it is very easy to see that NO equals to QN minus QO. I'll repeat again. NO, it is equal to QN minus QO. So NO equals to QN, that is 2 times the radius, 2R, minus QO, that is R. So in conclusion, I found out that NO equals to 2R minus R, that is R. So NO equals to R. NO equals to R. NO equals to R. QO is also equals to R, and QN, it is the diameter that equals to 2R. We will focus on the right triangle, triangle NMQ. In the right triangle, triangle NMQ, the sum of the angles is equal to 180 degrees. Which angles we have in the right triangle NMQ? We have 90 degrees. We have also this angle, that is angle theta, according to what is given as the question. We have also this angle that we will define as angle X. In total, the sum of those 3 angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. I'll repeat again. Here, in the right triangle, triangle NMQ, the sum of the angles must be equal to 180 degrees. That is to say, 90 degrees plus angle theta plus angle X. In total, they must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we will get that theta plus x equals to 180 degrees minus 90 degrees, it is 90 degrees. We'll subtract theta from this equation, and we get that angle x equals to 90 degrees minus theta. So we found out that angle x equals to 90 degrees minus theta, so we substitute angle x by 90 degrees minus theta. We also know that all the angles inside the square are right angles. So inside square ABCO we have 4 right angles. Those 4 angles are right angles. And because of the fact that NQ is the diameter of the semicircle, it is absolutely a straight line. So I write it down that NQ is diameter, it must be a straight line. NQ is a straight line. NQ is a straight line. And we have also rule number 2 that is related to a straight line. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? And we already found out that NQ is a straight line. So if we focus on the upper side of the straight line NQ at point O, then the sum of the angles on the upper side of NQ at point O must be equal to 180 degrees according to rule number 2. So which angles we have at point O? We have here 90 degrees. And we have also here angle AON. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. On the upper side of the straight line NQ at point O, we have two angles. One angle is a right angle, the other angle is angle AON. And in total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We'll subtract 90 degrees from this equation, and we get that angle AON will be equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle AON is a right angle, it is equal to 90 degrees. So we can write here that this angle, angle AON, is a right angle, it is equal to 90 degrees. Likewise, if you focus on the upper side of the straight line NO at point C, then the sum of the angles on the upper side of the straight line NQ at point C must be equal to 180 degrees. So which angles we have at point C? We have here 90 degrees. We have also here angle BCQ. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. In the upper side of the straight line NQ at point C, the sum of the angles must be equal to 180 degrees. At point C, on the upper side of NQ, we have two angles. One angle is 90 degrees, the other angle is angle BCQ. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation and we get that the size of angle BCQ, it is equal actually to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that angle BCQ is a right angle, it is equal to 90 degrees. We will continue to focus on the right triangle, triangle BCQ. In the right triangle, triangle BCQ, we have this angle that is equal to 90 degrees. We have this angle that is equal to theta. And angle, this angle that is angle CBQ. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles in any triangle equals to 180 degrees. We will subtract 90 degrees from this equation and we will get that theta plus the size of angle CBQ. In total, they must be equal to 180 degrees minus 90 degrees, it is 90 degrees. We will subtract angle theta from this equation and we will get that angle CBQ, the missing angle CBQ equals to 90 degrees minus theta. So we found out that the missing angle CBQ is equal to 90 degrees minus theta. So we'll focus on the right triangle, triangle A and O. This right triangle, we'll repeat on the same process here. On the right triangle, triangle A and O, the sum of the angles must be equal to 180 degrees. So which angles we have? Here we have this angle that is equal to 90 degrees minus theta plus this angle that is equal to 90 degrees plus the size of angle OAN. In total, the sum of those three angles must be equal to 180 degrees. Again, the sum of the angles in the right triangle, triangle A and O must be equal to 180 degrees. That is to say 90 degrees minus theta plus 90 degrees plus angle AON. In total, they must be equal to 180 degrees. Here we have 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees on both sides of the equation, so 180 degrees will get cancelled. And we're left only with minus theta plus angle AON, angle OAN equals to 0. We add theta to this equation and we get that angle AON, OAN, angle OAN is equal to theta. So we found out that angle OAN, this angle equals to theta. So here we found out that all the angles of triangle OAN can go to all the angles of triangle BQC. Both triangles have angle that is equal to 90 degrees minus theta. Both triangles have angle that is equal to theta, and both those two triangles have a right angle. Therefore, we can conclude that triangle ANO is similar to triangle BCQ. Repeat again. Triangle ANO is similar to triangle BCQ according to angle similarity rule. Okay. Triangle ANO is similar to triangle BCQ according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that CQ over AO is equal to BC over NO. I repeat again, from the fact that the two triangles are similar to each other, we conclude that CQ over AO equals to BC over NO. We will find out the value of CQ. What is the value of line segment CQ? CQ is equal to OQ minus OC. Okay, CQ equals to OQ minus OC. We define OC as A, and in this square AOBC, all the sides will be equal to A because of the fact that all the sides in a square are equal to each other. So here we found out actually that CQ equals to OQ, that is R, minus OC, that is A. So in conclusion, we found out that CQ equals to R minus A. We will substitute CQ in equation number 1 by R minus A. In equation number 1 we have CQ over AO. AO is also equals to A, and it equals to BC. BC is also equals to A over NO. NO equals to capital R. So in conclusion, we found out that according to equation number 1, R minus A over A equals to A over R. In the next step, we will divide this expression to two expressions. So according to equation number 1, r minus a over a equals to r over a minus a over a, that is minus 1, and it is equal to a over r. Okay. We will focus on the right triangle AON. On the right triangle AON, we know that tangent theta is equal to r over a. In the right triangle AON, tangent theta equals to r over a, so we can substitute r over a in this equation number 1 by tangent theta. We'll do it now, we will get that r over a is tangent theta minus 1 equals to a over r, but a over r is 1 over r over a. Now we can substitute r over a in equation number 1 by tangent theta. We'll do it now, and we will get that according to equation number 1, tangent theta equals to tangent theta minus 1 equals to 1 over r over a. R over a is tangent theta. We will multiply equation number 1 by tangent theta, and we will get that according to equation number 1, tangent theta times tangent theta is tangent square theta. And tangent theta times minus 1 is minus tangent theta. It is equal to 1. We will subtract 1 from equation number 1, and we will get that according to equation number 1, tangent square theta minus tangent theta minus 1 equals to 0. So we have here a quadratic equation. In this quadratic equation, the missing variable is tangent theta. Actually, the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula for x. X is actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. And in our specific quadratic equation, the coefficient a is equal to 1, the coefficient b is equal to minus 1, and the coefficient c is also equal to minus 1, and the variable that we are looking for is tangent theta, so x equals to tangent theta. So we put the data inside the equation for x, and we will find out the value of tangent theta, because x equals to tangent theta. So tangent theta equals to minus b equals to minus 1 in our specific quadratic equation. So minus b is minus minus 1, minus minus 1 is plus 1, plus minus square root of b squared. B is minus 1, so b squared is minus 1 square, minus 1 square is 1. Minus 4 times a is 1, times c is minus 1 over 2a. A is 1, so 2 times 1 is 2. So here we have tangent theta equals to 1 plus minus minus 4 times minus 1 is 4, and 4 plus 1 is 5. So inside the root we have 5 over 2. So here we will have two solutions that are possible for tangent theta. The first solution is tangent theta is equal to 1 plus square root of 5 over 2. And the second solution is a negative solution. Tangent theta equals to 1 minus square root of 5 over 2. That is negative, it is less than 0. So here we have in the right triangle NMQ, we have this angle MNQ equals to 90 degrees minus theta, and this angle that is inside a right triangle, it is absolutely a positive angle. So we can write down that 90 degrees minus theta is greater than 0. We will add theta to this equation and we will get that theta is smaller than 90 degrees from one side, but here we have angle theta. This is the angle that we are looking for. You can see from the drawing that angle theta is absolutely a positive angle, so it is greater than 0. From one side theta is greater than 0, and from the other side theta is less than 90 degrees. So we can write down that angle theta from one side is greater than 0, and from the other side it is less than 90 degrees. In this range of angles from 0 to 90 degrees, tangent theta is a positive number. Tangent theta is greater than 0 when theta is from 0 to 90 degrees. So we got that the tangent theta must be a positive number, but according to the second solution, tangent theta is less than 0. It is a negative number. So we have here a contradiction. Therefore, tangent theta, the second solution, is incorrect solution because we got to a contradiction. Tangent theta must be a positive number, and according to a second solution, it is a negative number. Therefore, this solution is incorrect solution. We will cancel this solution, and we left only with the solution that tangent theta, with the first solution that tangent theta equals to 1 plus square root of 5 over 2. And we want to find out the value of tangent theta itself. In order to find out the value of tangent theta, we will operate the inverse function of tangents on the result, that is 1 inverse function of tangents on the result, that is 1 plus square root of 5 over 2, in order to get the value of theta itself. And we get that the inverse, if we operate the inverse function of tangents on the result, that is 1 plus square root of 5 over 2, we will get that angle theta itself equals to 58.28 degrees. So we found out that angle theta equals to 58.28 degrees. That is the angle that we are looking for. Here, this angle theta equals to 58.28 degrees. So in the next step, I will summarize the lecture. Actually, we wanted to find out the size of this angle theta. We have in the drawing a quarter circle. This is a quarter circle, inside this quarter circle we have square ABCO, and we have angle AMB, that is a right angle, and we have angle BQC, that is theta, and this is the angle that we are looking for. So in order to find out the value of angle theta, we made a construction. We extended line segment MA by a straight line, and we extended line segment QO by a straight line also until they intersect with each other at point N, and we completed the quarter circle to a semicircle. So we have here a peripheral angle NMQ, that is a right angle, and we have rule number 2 that states that any peripheral angle that is equal to 90 degrees must rest on the diameter. And because of the fact that the peripheral angle NMQ is equal to 90 degrees, it must rest on the diameter. That is to say, NQ is the diameter of this semicircle. So according to rule number 1, NQ is the diameter of the semicircle, and we know that in this quarter circle, OQ must be equal to the radius. And we already found out that NQ is the diameter that is 2 times the radius. Therefore, ON will be equal to NQ minus QO. ON equals to NQ minus QO. NQ is 2R, QO is R. So in conclusion, we found out that NO equals to R. That is the radius of the semicircle. Okay, then in the right triangle NMQ, we know that the sum of the angles must be equal to 180 degrees. We have 90 degrees, we have angle theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles to 180 degrees in the right triangle NMQ. So NQ, it is the diameter of the circle, therefore it is absolutely a straight line. NQ is a straight line. And according to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line NQ at point O, then the sum of the angles must be equal to 180 degrees according to rule number 2. At point O we have 90 degrees, and we have also angle AON. In total, the sum of those two angles must be equal to 180 degrees. According to rule number 2, we subtracted 90 degrees from this equation, and we found out that angle AON is a right angle. This angle is a right angle. Likewise, the sum of the angles at point C must be equal to 180 degrees. 90 degrees plus angle BCQ must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle BCQ, this angle equals to 90 degrees. Then, in triangle BCQ, the sum of the angles equals to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So we have 90 degrees, we have angle theta, and we have angle BCQ. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that the missing angle CBQ equals to 90 degrees minus theta. Likewise, in the right triangle AON and ANO, the sum of the angles must be equal to 180 degrees. That is to say, the right angle that is 90 degrees plus angle, the other angle that is 90 degrees minus theta, plus angle OAN. In total, they must be equal to 180 degrees. We have 180 degrees on both sides of the equation. So 180 degrees will get cancelled, and we left only with minus theta plus angle AON equals to 0. From this equation, we derive that angle AON equals to theta. So actually, triangle AON and triangle BCQ have the same angles, therefore they are similar to each other according to angle similarity rule, And from the fact that they are similar to each other, we will conclude that CQ over AO equals to BC over NO. CQ equals to OQ minus OC. So CQ equals to OQ, that is R, minus OC, that is A, according to our definition. So we found out that CQ equals to R minus A. So we can substitute CQ in equation number 1 by R minus A. And we get that CQ is R minus A over OA, that is A, equals to BC, that is also A, over ON, that is R. Here we divided this expression to two expressions, and we got that according to equation number 1, R over A minus 1 equals to A over R. In the right triangle, triangle AON, we know that tangent theta equals to R over A. Tangent theta equals to R over A in the right triangle AON. Therefore, we can substitute R over A in equation number 1 by tangent theta. We did it and we got the tangent theta minus 1 equals to A, and A over R is 1 over R over A. So we can substitute R over A by tangent theta. We did it and we got the tangent theta minus 1 equals to 1 over tangent theta. We multiplied equation number 1 by tangent theta, and we got here that tangent square theta minus tangent theta minus 1 equals to 0. We had here a quadratic equation. We solved this quadratic equation and we got to two solutions for tangent theta. The first solution is 1 plus square root of 5 over 2, and the second solution is the tangent theta equals to 1 minus square root of 5 over 2. That is a negative solution. But here, tangent theta itself is between 0 to 90 degrees, and in this range of angles, tangent itself is a positive number. Tangent theta is a positive, therefore, and we got, according to the second solution, tangent theta is a negative. So we got to a contradiction. So the second solution is incorrect solution, and we left only with the positive solution. The tangent theta equals to 1 plus square root of 5 over 2. And if tangent theta equals to 1 plus square root of 5 over 2, here we will operate the opposite function of tangents, that is inverse tangents, on the result in order to get the value of theta itself. And when we operated the opposite function of tangents on the result, that is 1 plus square root of 5 over 2, we got that theta itself equals to 58.28 degrees. So in conclusion, we found out that the size of this angle, angle theta, the angle that we are looking for, equals to 58.28 degrees. I'll repeat again, the size of this angle, angle theta, it is equal to 58.28 degrees. Okay, thank you very much.